So the idea for this book originated from, I suppose, years of research, of experiments and different projects. Personally, I and other colleagues have been doing. So the way I structured this book is I've been working on a number of articles and for different journals. So I've been publishing quite a lot, and then I've been doing different projects. So, and then after probably 4 or 5 years of this work, I felt it was a time to actually try to combine everything into one place, and therefore that's why I approached Routledge and with my idea for this book, the Urban Study and Geography book series, and they loved the idea, they liked the idea, and then we discussed the timing of this work and just start working on it. So obviously this book is structured in a hybrid form, in that it can be very, very interesting for architects, for urban designers, urban planners who are interested in understanding and work with new tools, digital tools, algorithmic thinking, computational strategies for design. But equally, it's interesting for scholars and for people who actually simply study this topic, and also on a third level, it can be quite interesting for everybody else. So students, master students who are interested in the subject, in the topic. It's simply because architecture, as we know, and the world design is changing dramatically, is going increasingly towards a digital side of things. Even the old school approaches somehow are combined with digital tools at a certain point of the production. So literally this book is quite interesting. And also what I personally find quite interesting of this work has been the fact that I really like to escape from this idea of black box technology. Something like, when we think about algorithms or we think about computers, sometimes we imagine this very complicated, very obscure series of mechanisms that nobody can understand, but somehow they work. Think about artificial intelligence. It seems like this mysterious entity where things are inputted, and then this computer will actually do something with this data, do something with what the computer actually can analyze, and then this computer will take some decisions. So that's, I suppose, what I find fascinating in my work is this work is the fact that I've been trying to unpack all this and trying to open, if you like, this black box and see what's inside. So I start studying and looking at some of the mechanisms that are behind this, and so looking at the algorithms, the way they're written and the way they work and why and what they do. So that also includes I suppose the potentialities of the algorithm, but also the limitation of them. So in a way, I've been doing in this book, I've been looking at different algorithms and the way in which they are used, but equally the extent to which they actually are applied to design. So the book is structured in 3 parts. The first part is about the tension, if you like, between the idea of continua, and the idea of discrete and discretization. So obviously I go back to Democritus and the origin of all this, I suppose, the discussion, and I really look at the moment where the world has been seen as a series of atoms, and then also I look at the evolution of this tension down to what happened with quantum computing and to granular computing, and also the second part of this first section is about the way in which we actually use these notions. So looking at the idea of voxels, for instance, in design, or fractals, so the fact that you can actually develop space, you can build space based on a kind of discrete level, based on discrete and granular steps of production of space. The second part of the book is about looking at the really the techniques and the way in which discrete space works. So in chapter 3, for instance, I have a series of examples of algorithmic thinking. So I've got a series of projects which I analyze, and also a series of projects which I've done together with some other colleagues. And then I basically open up this project, I open up these algorithms, and we're looking at how they work from a statistical perspective, from a mathematical perspective, how they look like, what are they? So we show some mathematical formula, we show how they work and why they work, but we also show their limits. We also show so that sometimes there might be some bias within the numbers, and that's quite exciting, really. So then the second part of the second section of the book is dedicated to actually the application of this logic into space. So we're looking at how architects and designers in general, and urban designers, will actually use all this technology in their projects. So we're looking at, for instance, BIM and CIM, and also other technologies that are currently used by all of us. And then we're looking at how they work and why they work in that particular way. And it's all based on what we discuss in the chapter 3 and in the first section, obviously. Now, the final part of the book is dedicated to the idea of public space and how all this discrete logic and this computing logic is actually transforming the space in which we live, in which we move. And so I came up with this idea of a new type of public space, new type of space, which is in actual fact is an assemblage of 3 elements. So there's the built environment, that's the presence of what I term in the book I call software, but in actual fact is everything that includes computing or code, so I use a lot of this terminology in the book as software referring to sort of very generic entity that encompasses everything that has to do with the computing logic. And the third part of this assemblage is dedicated to the individuals. So again, you can imagine this tripartite structure where you have the individual on the one hand, then you have the built environment, so everything we can actually touch, so the traditional architecture, brick and mortar architecture, if you like, and then in between them is the software. So obviously this book talks about design, talks about algorithm and computing in design. The interesting thing that I found working in this research is the fact that all design is changing in a very, very significant way, even if we don't really realize that, or rather we don't realize the extent to which this is actually changing. We think that some of the tools that we use, they are traditional, they are old school, but in reality they are underpinned by very complex computer-based logics. One example that comes to my mind, which is quite kind of guide me through the work, especially the final part of this work, is the fact that the more and more the architectural offices, the big ones, are including a very new and particular expertise in their offices. They have people who are able to actually not only use digital software but actually design their own software. So instead of having, the traditional model is that we have massive companies, computer companies, software companies that basically produce software, then all the architect and designer will actually buy the software and use the software. But more and more we witness the fact that we have offices that have this hybrid figure in the staff who are able to actually not only design but also design the software. So, and they are software engineer on the one hand, but also they are architect on the other hand, which is quite interesting mix. So the idea is that offices are designing their own tools, and by doing that, they are actually increasing the freedom, if you like, in the way in which they can design their own building or their own projects. So design is changing dramatically, and I personally think that this is just the beginning. So we'll see more and more of these. And again, it's always start with the big firms, Saat's or Foster's, SOM. But then, it will eventually, that's my guess, it will eventually trickle down to the medium-sized firms, even the smallest firm, because we also see from our students, our students are increasingly interested in coding, in scripting, in parametric design, way more than there was in the 90s, where in the 90s we only were, actual playing with shapes and trying to use different software or different parametric logics to actually find shapes or design more interesting shapes. Basically, it was an exploration of shapes. Now it's completely different. Now we design tools for optimization, for data analysis, to actually, what we're doing now, we're not exploring anymore, we're actually improving significantly our design quality. So this research, I think that the work I've done for this book is, I consider it completed. So there was an exploratory phase where I was looking at the algorithmic structure of the design thinking and the tools that are available so far and the way in which we can use them, but also where they come from. So from the, I suppose, the historical perspective or the philosophical perspective. But then now I think I moved on a little bit from these, and I won't lie to, I'm actually doing now more experiments with agents and with artificial intelligence. And I suppose I'm working on a number of projects now and experiments, and I suppose my next book will be probably, most likely, presenting all these projects. And then again, as usual, with my, I suppose, methodology, I will work on this project for a few years, and then I will probably try to wrap everything up into a new book. Yes.